Alright, so back with another fun video for anyone who's interested. I finally got my Arduino here, which I waited for about a week after ordering it. Had a little bit of problems with the distributor, but finally got it. Done a really basic little setup here to sort of just demonstrate one of the many functions of this device. Basically what this board does is it allows me to connect a USB plug into it, which will not only power things such as LEDs, but this board acts as a way to actually program this chip here. This is a AT Mega 168 chip, and basically that can hold programming language. It's programmed on there onto its memory to execute basically whatever you program it to do, and then it can control a myriad of different pins out, and these can be set to inputs and outputs, and basically it's a cheap way to get into microcontrollers and just kind of play around a little. What's neat about this, if you've seen my previous videos with setting up the sort of like the blinking lights and whatnot with the amps and the timers, that's sort of a physical means of achieving what can be pretty easily achieved on this device with just programming. So here's actually the I'm not sure how well you'll be able to see this. It's coming up now. So actually, for this, this is a blink script that came with the Arduino development suite, and I've sort of modified it some to do just a little bit of different things with the LEDs. But you can see it's pretty much it's programming language. It's a variant on the C programming language, and it's really pretty basic, honestly, if you just take a little bit of time to sort of look at it. But I thought I'd just show you a real quick demo here. Basically, here we have defining which pins are being used on the physical board itself. So basically, it comes to light here. It means like which pins I'm actually plugging the LEDs into. And in my case, I have 9, 10, and 11. The three lead pins coming out to the LEDs. So you see there, I'm defined as 9, 10, 11. Define 9, 10, 11 as outputs because I'm sending power to the LEDs from those pin locations. And then we actually get into the loop. This is a main part of the program, if you will, that it'll just run this over and over. And basically what I have here is just you see pin 11 will be high. That means it'll be getting power. It'll do that for 1,000 time periods. This is actually in milliseconds, so that's 1 second. And then it'll go to low and stay at low for a second, and then it'll do that over and over and over again because it's in the loop function. So let me actually plug it in. And it'll go through a little boot up period, and then you actually see the LED, and it's 1 second 1 second intervals. What's great about this is pretty much that is being achieved with 6 lines of code versus a good amount of calculations and using capacitors and resistors to set up those timers properly like I was doing before. So you see how this makes things like that really a lot easier, and it's sort of my best option for some of the projects that I'm trying to undertake. So I'm gonna actually change the setup a little bit and come back and show you what some of this commented out code right here will do. So okay, as you can see here, I've uncommented some of this code. Pretty much just to explain the code rather quickly, it begins by lighting up the first light for 1 second, and then turns off the first light. You see first light on, the 11 light on, hold for a second, 11 light off with a low, and at the same time as that the 11 pin LED is being turned off, the 10 is being turned on. So it does that for a second, and then the 10 is turned off, 9 pin is turned on, delays for a second, and then 9 is turned off and 10 is turned on, so it goes back up, waits for a second, and then basically turns the 10 off, and then it loops back to the top, turning the 11 back on. Basically, let me go ahead and upload this to the board. You can see the board is doing a little bit of thinking there, loading the code. So as you can see, the lights are following along with the logic that I gave it. So it's pretty useful for running things concurrently or in sequence like this. So and what you can do is I'll go ahead, come in here and change these delay values, so basically the amount of time that each light is lit up will be a lot less. So I'm changing all the 1 second or 1,000 millisecond values down to 50 milliseconds. So it'll be pretty rapid. So let me upload it to the board. You can see here the board doing its little thinking there. There's little activity lights, and then there you go. So as you can see, the rate at which they are alternating up and down in sequence is much quicker now. So a lot you can do with these. Like I said, I've got a couple of projects already in the pipe. I've done some coding for them already. I just need to test them out with the actual board. So it's a pretty powerful tool. It can definitely do a lot more than just power LEDs, at least just on the outright. So these can be used to build robots off of, and to create a myriad of various devices which require the use of a microcontroller. So if anybody's interested in this stuff, I encourage you to go to, actually it's Arduino.cc is the main site for this device. You can see Arduino there at Arduino.cc, but tons of information. It's all open source, and so really there's lots of code out there for you to download from others and edit to meet your project needs. So I look forward to doing a lot of stuff with it, and I'll definitely keep everybody posted on what I do.